Martin here on the Kuadrant team. I'm going to show a short demo of using the multi-cluster gateway controller with Skupper. This will be based on the doc here, the walkthrough Skupper using two gateways for resiliency. So what is Skupper first of all? In its own words, Skupper is a layer 7 interconnect. It enables secure communication across Kubernetes clusters with no VPNs or special firewall rules. So how does that apply here? So looking at the architecture we're going to have in our demo here, we'll have two clusters. We'll have a gateway on either cluster. That gateway is going to be managed by the multi-cluster gateway controller. So we'll have one gateway centrally, and then that propagates into two gateway instances, one on either cluster. Our application behind that gateway will have a HttpRoute service and the pod. It's a very simple pod, just echoes back whatever you send to it. Where Skupper comes into play is at the service level. So we'll have a Skupper router running on either cluster, and those two, that Skupper network will have a link between the two sites, and that allows the service here to kind of go into a resiliency kind of mode, where it can send traffic to the local pod, but if that pod, or if the service rather isn't healthy because there's something up with the pod, it will send the traffic over the Skupper network instead to the service on the other side, and vice versa. So there's a good few steps in here. I've already set this up though, so I already have the architecture that you see here in front. What I'll do is I'll show it in action in terminals here, and then I'll demonstrate the resiliency aspect of Skupper. So I've 4 terminals here. The terminals on the left will be for the first cluster. The terminals on the right will be for the right-hand side cluster. I'm just tailing logs of the echo server on the first cluster here, on the second cluster here, and we can send some commands to either cluster up here as needed. So first of all, I've already sent some traffic here using curl. So I have a little loop here that just curls every few seconds to the host name of our app. So the host name of our app here is testtree.dm.httpapps.net, and depending on what DNS response it gets, it'll hit one or the other gateway. So there's DNS load balancing at play. Now there's other aspects of DNS that the multi-cluster gateway controller can provide, such as geo, but for this it's just plain round robin load balancing. So we can see traffic hitting either cluster depending on what the DNS response is. We can get a look at what those addresses are. I have a command here to pull out the addresses from the multi-cluster gateway. So we can see here there's 2 different addresses here. And those addresses are what's in the DNS record. Okay, so the resiliency piece. So by default, if we jump back to the diagram, the service here, which has been kind of taken over by Skupper, it will use waiting to determine where it'll send traffic. And by default, it should send the traffic to the local pod. Let's have a closer look at the service itself in either one, just to see how Skupper actually works. So here's our echo service. Let's have a look at the YAML of that. We should see a couple of interesting things. Now, when originally created this service, our selector was going to our echo pod, But we can see here that the selector is actually now saying, look for an application. So based on labels, look for an application called Skupper router, and have this label of the component is router. Now, that's not what we originally set on the service. So Skupper has done something here for us. So what did we originally have? Well, Skupper just stores that in a couple of, we say, annotations up here. What was the original assigned port, the original selector, the original target port. So if you decide you no longer want to, say, expose this service over the Skupper network, Skupper will take these original annotations here and apply back whatever they should be. So for now, what it's doing when you hit this echo service, it actually goes to this this pod here, the Skupper router. We can see that here if we have a look at the pods. So there's the Skupper router right here. And if we have a look at the labels, we should see those labels from the service. So application Skupper router and component is router. So that's how Skupper works. It will redirect the service, for want of a better term. So the resiliency piece. So let's keep curling here and just see what happens if we were to take down the pod on one of those clusters. So say the right-hand cluster here, we would hope that the traffic coming into this gateway will hit this service and then go over the Skupper network to the other side. So from the gateway's point of view, it doesn't know anything about Skupper. So that's the nice piece here. We can leverage Skupper without having to do anything special with our gateway or our HttpRoute. It all happens at the service level. So we should have a deployment for our Echo server. And if we were to scale that down, let's have a look at that. Let's scale that down to 0. Let's clear these logs on both sides. So once we scale this down, we should see some, we might see an error or two on the right hand side, and then we'll see no more traffic hitting this one. We might see an error or two up here in our curl responses, and then it should start hitting the left hand side. Okay, so that's scaled now. In fact, we don't have the pod anymore, so we can't see the logs. On the left hand side here, we're getting all the responses. And we can see if we scroll up a little here, the request is served by this particular pod, WSTTL. If I cancel out the logs for a sec, we can see that's the pod that we're tailing the logs of. So that's it. We introduced Skupper to add some resiliency with the services across the two clusters.